Hi, welcome to lesson 9.7. In today's lesson, we are going to talk about two very important laws of trigonometry. So the first one is the law of sines, and the second one is the law of cosines. And we're going to be using sine also in order to find some areas of triangles. Now, let me just warn you, today's lesson is going to be a bit long because it should really be two lessons, but we're going to do it in one lesson. So first thing you need is a blank piece of paper, and I want you to glue this on page 272. Okay, and this is going to be for problems number 6 and problem number 7. Okay, so pause the video and go ahead and glue that. Now, the second piece of paper that you need goes on page 273, and that's going to go for problem number 8. Okay, so 273, problem number 8. Now, you will be putting example number 1 on page 274. Example number 1 here at the top. It doesn't require a lot of space. So you're going to put problem number 1 right there. You're going to put problem number 2 right here. Problem number 3 right there. That's on page 274. And on page 275, you are going to be putting example 4 and example 5 right here. Now, as you can see, we are going to be actually deriving the law of cosines in just a second. We're going to be deriving the law of sines in just a second. And we are going to be developing the area equations for a triangle whenever you do not have the actual altitude. Because we know that the area of a triangle is literally the base times the height. But in this case, we do not have the actual altitude of the triangle. So we need an alternative method. Now, since we do not have any space in our 9.7, I want you to use 3 separate pieces of paper in order to take the notes. So go ahead and get those pieces of paper and start the video whenever you're ready. Okay, so the first thing that we are going to look at is the area of a triangle. Okay, so I'm going to zoom in a little bit just so that we can have a little bit more. There you go. All right. So first thing we're going to do is we're going to discuss about the area of a triangle. All right, so what we're going to do first is we are going to draw a triangle. It doesn't have to be a right triangle. It could just be literally any triangle. All right, we're going to call this one here A, B, C. Now, the side opposite of angle A is going to be length A, length C, and this will be length B. Okay, the lighting takes a little adjusting, but it's right there. All right, we're going to drop a perpendicular, as shown right there. And we're going to call this the height of the triangle. Now, we do know, okay, let me fix the lighting, please. Okay, I was having issues with the lighting. All right, so we know that the area of any triangle is 1/2 the base times the height. Now, the only problem is that the problems that you will encounter do not have the actual height. Okay, so we need an alternative to that. So here's what we're going to do. Let's look at the sine of angle A. Okay, so the sine of angle A happens to be the altitude over the hypotenuse. All right, so then what we're going to do is we are going to put a 1 under this and cross multiply and solve for h. So this equation would look like this. C multiplied by the sine of A. Okay. All right, let's take a look also at the sine of C. Okay, so the sine of C is going to be h over A. And we're going to do the same thing. Cross multiply. And we are going to get H to equal A times the sine of A. Nope, C. All right, so now what we're going to do is we're going to look at what exactly is going to be our area now. All right, so our area in this case is going to be the base multiplied by the height. Okay, so it's going to be divided by 2, of course. 1/2. Now the base here happens to be B, and the height, I have two heights, so let me start with this one first. C sine of A. Okay, so the area is 1/2 B times C sine of A. But I can also do the following. The area could be 1/2, okay, the base, which is B, multiplied by A sine of C. Okay, so if I were to fix this and put the A in order, this is the same thing as 1/2 A times B sine of C. Now, if I were to draw the altitude in a different direction, I would be able to derive the alternative equation, which is 1/2 A times C sine of B. Now, how do you know which one to use? Well, that really depends on what it is that you are given. If you are given A and B, you'll probably know what angle C is, and you'll be able to derive the area of the triangle. So this is how those equations got derived, okay, for the area of a triangle. Let's go ahead and focus now on the law of sines, which uses pretty much the same idea. Okay, so for this, let's talk about the law of sines. Now, what is the law of sines? The law of sines and the law of cosines is used whenever you cannot find the missing side of a triangle, when your triangle is not a right triangle. Okay, so it's going to be for whenever the triangles are, not going to be right. Okay. All right, so it's going to look something like this. Still thinking the lighting is any good right now. All right, so let's look at a triangle like this. A, C, B. Once again, you have little a, little c, little b. Now what we're going to do is, again, we're going to drop an altitude. We're going to call that H. Now let's go ahead and look at something. The sine of A is going to be equal H over C. Okay? The sine of C is going to be equal H over A. Cross multiply, put it over 1, put it over 1. Cross multiply, you're going to get H equals C times the sine of A. Do the same thing on this one. H equals A times the sine of C. But remember, both of these H's are the same, which means that these two right here are exactly the same. So when I equal them to each other, C sine of A equal to A sine of C, I'm going to divide both sides by C, and I'm going to divide both sides by A. Now what's going to happen is that these are going to divide, these are going to divide, and I have the sine of A over A equal to the sine of C over C. Now if I was to draw the perpendicular in a different direction and go through the same process, I would end up with the fact that the sine of B over B is going to be equal to these right here. Now it's kind of bugging me that these are not in order, so I'm going to go ahead and just fix them. Not that I have to, but I want to. Now you can also use the reciprocals of these, meaning A over sine of A equals B over sine of B equals C over sine of C. So you can use them, you can use these two together, you can use these two together. It all depends on what you really have. So, ladies and gentlemen, this is how the law of sines gets derived. So these two have been pretty easy. The law of cosines is a little crazy. So we're going to go a little slow on that one so we can understand it completely. All right, so for the law of cosines, here's what we're going to do. All right, for the law of cosines, we are going to start off with the same triangle that we have been using. Okay, we're going to label it A, B, C. This side right here will be little a, this side right here will be little c, and all of this distance right here, of course, we're going to call little b. Now you're probably thinking, why is he doing like that? Well, that's because when I drop my perpendicular, I'm going to actually be dividing this into two segments. So I'm going to call this segment right here x for right now. Okay, let me zoom in a little bit. And therefore, I'm going to be calling this distance right here b minus x. All right, so we're going to develop these using Pythagorean theorem. All right, so would you agree that a square, that's this one, is equal to, I'll get my h here, h squared plus b minus x quantity square. I mean, it makes sense, right? Pythagorean theorem. This quantity square plus this quantity square equals this right here. Now, if I was to simplify this, it would look something like this. Okay, that would be b squared minus 2bx plus x squared. And let's just leave that for right now. Okay, let's take a look at something else also. Let's take a look at this side right here. Okay, now on this side, we have c squared equals x squared plus h squared, right? So look, if you identify this, this and this is exactly that, okay? It is exactly that. So what I'm going to do is I'm going to replace that, okay? I'm going to put my b squared minus 2bx. I'm going to replace that with a plus c squared. All right, because of that plus. So I'm going to put that actually, probably should have left some space there. Okay, I'm going to replace that with the c squared right there minus 2bx. Now, let's take a look at one thing here. Okay, the cosine of angle A is x over c. Cross multiply, and you're going to get c times the cosine of A equals x. So what am I going to do with that x? I'm going to replace it with that one right there. So then that's going to give me a squared equals b squared plus c squared minus 2bc cosine of A. So that, ladies and gentlemen, is how you derive the law of cosines. Now, here's the thing. Well, what if I want to know what b squared is? What if I want to know what c squared is? The process will be exactly the same. Okay, so the equations are actually going to look like this, using the same process. I'm not going to go repeat all this. Okay, so that's going to be b squared equals a squared plus c squared minus 2ac cosine b. Notice this is how you can remember it. Okay, this is the lowercase and this is the capital. Okay, so a bc bc b ac ac. Okay, so c squared is going to be a squared plus b squared minus 2ab cosine of c. So whichever is the one that you are going to need to use, you have to, see which one is going to be which. So you probably have to label them A, B, C in order to be able to apply one of these theorems. One of these equations. So this is how the law of cosines gets derived. Now I know we're already 15 minutes into the video, And we haven't even started the examples. Okay, so but we're going to go ahead and do that. By the way, this is called the law of cosines. So pause the video so you can finish taking the notes. All right, let's go ahead and begin the examples now. Okay, for the examples, the first problem is extremely easy. All right, so all you got to do is literally have a calculator. So the tangent of 150, now in this kind of calculator, I have to type in 150 first and then press the tangent button. Now you have to make sure that you are in degree mode and not in radian mode. So my answer to the tangent of 150 is negative 0.5774 because I'm rounding it to the nearest 4 decimal places. For the sine of 120, that gives me 0.8660. Cosine of 95. Well, let me make sure I did that one right. 120 sine. Yes. Okay, 95 cosine. That is negative 0.0872 because of that 5. All right, so example 1 is extremely easy. That's all we have to do. And like I said, there's 8 examples, so bear with me. Try not to make the video too long. Okay, find the area of the triangle and round the answer to the nearest tenth. So here's where our equations for the area of a triangle are going to come in handy. So notice I have them right here. Okay. All right, according to what I have here, I have A, B, C. Okay, I'm going to call this part here little a. This part right here is going to be little b. This one here is going to be called little c. All right, so which one am I going to be using pretty much? Okay, well, I need the one that has BC, so it's going to be this one here. Okay, I don't know if you can see it. This one right here. Okay, that one right there. Where the area is going to be 1/2 little b. Little b happens to be 17. Little c happens to be 19. And the sine of angle A, which is 135. So after this, it's all about typing it into the calculator. Okay, so let's see. 17 times 19, that's 323. Okay, so I'm going to keep simplifying this. The sine of 135 is about, let me make a little more space here, 0.7071. I'm going to multiply this by 323 and then divide it by 2. So the area of this triangle right here is going to be 114.2. Now, once again, how did I know what it is that I needed to use? Okay, well, very simple. I look at my equations, okay, and I look at my diagram and I see what I have. You see how I label these? I have little a here that is not given to me. I have B and I have C. Okay, so out of these 3 right here, probably the one I wanted to use was this one right there, because I know what B is, I know what C is, and I know what angle A is. All right, so that one was example number 2. Okay, so it says solve the triangle. Now when it says solve the triangle, it says pretty much to solve for everything. Now on this one, we are going to use the law of sines. Okay, so what we have here is we have A and we have little a, you would say. Okay, so we have A and C, but we don't know angle B, so I can't use the, actually no, never mind, get back. We are trying to find out what B is and what C is. I can't find out what C is until I know what B is. So I'm going to do the following. The sine of A over little a is going to be equal to the sine of B over little b. And I know what these are. I know what angle A is. Angle A is 115. Little a is 20. I don't know what the sine of B is, so we're just going to leave it right now as is. But I do know that little b is 11. So as you can see, we only have one unknown. All right, so what we're going to do is we're going to cross multiply. And I'm actually going to leave the 20 right there where it is. I'm going to multiply 11 on both sides. And I'm going to end up with the sine of B equals 11 over 20 multiplied by the sine of 115. So I'm going to calculate what the sine, actually I'm going to do 11 divided by 20 first. This is all about decimals, guys. 0.55 multiplied by the sine of 115. All right, so when I multiply that, I get the following. 0.4985. And that's equal to the sine of B. So my goal is to now find what angle B is. So what I'm going to do is I'm going to do the inverse sine of 0.4985. And that's going to be equal to the measure of angle B. So the measure of angle B, according to my calculations, it's going to be to the nearest tenth, 29.9. So it's about 30 degrees. Okay. So now this is because I did a couple of approximations. Okay. So let's just say it's about 30. Now let's leave it 29.9. Okay. So this is what B is. All right. So the measure of angle B equals 29.9. We already know the measure of angle A. Okay, the measure of angle A is 115. So to find the measure of angle C, all you have to do is add those two together, subtract it from 180. So 29.9 plus 115, subtract that from 180 degrees, and I get approximately 35.1. So the only thing that I am missing now is what is the measurement of little c? And I'm going to use this ratio that I had here already to find out what that is. So I know I'm running out of space here a little bit, so I'm going to zoom out a little bit. So I have the sine of 115 over 20 equal to the sine of c, which in this case is 35.1 over little c. Cross multiply and divide, and you're going to get c is going to be equal to 20 sine of 35.1 over the sine of 115. All right, so let's calculate that. So the sine of 35.1, okay, multiplied by 20. Now I'm doing all this work on the calculator, guys. So that's about 11.5 divided by the sine of 115, which is about 0.9063. Let me go ahead and put that in there. 11.5 divided by 0.9063. I get approximately 12.7. So C is going to be about 12.7. So we have now solved for the whole triangle because we already know A, we know B, we just found out C. We already know angle A, we calculated angle B, and we calculated angle C. So we have solved for the triangle. All right, so if you need to pause the video, do that right now so you can copy it down. All right, let's take a look at example number 4 now. Okay, we're halfway there, guys. All right, so let's go ahead and solve for the triangle again. Now, I already know what angle B is and what angle C is. So I am looking for the following. I'm looking for the measurement of angle A. I'm looking for the measurement of A and the measurement of C. These are the three things that I need in order to fully say that I solved for the triangle. Now, to find out angle A, that one's actually the easiest one because all you have to do is the measure of angle A happens to be 180. Take away the sum. Yes, that is the bell, guys. I'm recording this before school, so now kids get to go to class. I have first period prep, so I have nothing coming in. I have no one coming in. All right, so 180. So excuse the noise. It is a school. All right, 107 minus 25 happens to be 82. So 180 minus 82, and you'll probably hear the late bell right now, about 6 minutes. So then that's going to be 98 degrees. So the measure of angle A is 98 degrees. And that's my phone. All right, so that is going to be 98 degrees. So that's easy. Now all we got to do is find out what angle C is, what side C is and what side A is. So I'm going to have to do two different calculations here. Now the only one that I know the angle and the opposite side to is angle B. So the sine of angle B over 15, okay, it's going to equal to the sine of angle C, which is 107, over C. And that's how I'm going to solve for C. Now, to solve for A, I'm going to still use the same ratio. But in this case, I'm going to use the sine of 25 over, actually, 98, my bad. Come on, Osuna, using the wrong angle. The sine of 98 over little a. And that's how I'm going to solve for A. So when you cross multiply and divide, you're going to get C equal to 15 sine of 107 over the sine of 25. And here, when you cross multiply, you're going to get A is equal to 15 sine of 98 over the sine of 25. And I'm cutting corners here. All I literally did was cross multiply and divide, and that's how I'm going to be solving for these. So, calculator time. You need a calculator for all this, guys. So, 107, the sine of that, times 15, gives me 14.3, I'm going to round to the nearest 10, over the sine. Actually, no, I should take it back. I should really do at least 2 decimal places, just for accuracy reasons. Sine times 15. So that should be 4. The calculator is doing all the work, so let's go ahead and just use 4. Why not? Okay, so 25 sine. Okay, then we're going to go ahead and divide that. And I get C to be about 33.9. And now for A, sine of 98 times 15, that's about 14.854. The next one is a 0. So the sine of 25, 0.4226. Okay, so 14.854. There's a lot of calculations, let me tell you. I get approximately 35 point, to the nearest 10th, 1. Hence now, we have now solved for the whole triangle. So take a minute to copy it down, to go through it, to understand it. Pause the video if you need to, before going on to example 5. All right, let's take a look at example 5 now. Now you have this, looks like a lake or a picnic area. That's a north picnic area, an east, and a south picnic area. A surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from the north area, picnic area, to the south picnic area. So find the length of the bridge. So they're technically asking me for C. But we're going to go ahead and find out pretty much everything since we're cool like that. So we're going to be looking for length A. There's the bell again. Okay, make sure you're always on time to class. We're looking for C, and we are looking for the measure of angle B. Now, angle B is the easiest one to figure out because all you got to do is 180 degrees. Take away that from the sum of 71 and 60, which happens to be 131. So when you subtract that from 180 degrees, that's going to be 49. So that one's easy. We are still using the law of sines in this problem. Okay, so the one that we already know, since this one right here is 49, we already know the angle and the opposite side to it. Okay, now technically the question is only asking for C, but we're going to calculate A anyways. So let me go ahead and divide this into 2. So we are going to use the sine of 49 over 150. Notice I don't use the reciprocal one as much. I'm not really a big fan of it. I like them like this. I like the signs on top for some reason. Now, in this case, I'm going to try to find C. So this is going to be the sine of 60 over C. Now, to find A, I'm going to still use the sine of 49 over 150 and the sine of 71 over A. So once again, I'm going to cross multiply and divide, and I'm going to get C equals 150 times the sine of 60 over the sine of 49. And on this side, A is going to equal 150 sine of 71 over the sine of 49. So after this, it's all punch in the calculator and, get your decimals. So that's what I'm doing right now. I'm typing it over here on the side. Up here, I get 129.9. The sine of 49. And guys, these are going to be approximates, okay? All right, so 129.9 divided by 0.7547. I get an approximately 172.1. Now I'm going to do the same thing for this side. Okay, times 150. That's going to give me 141.8 over the sine of 49. All right, so 141.8. Type that in right, Osuna. And you guys can always check my math if I made any mistake. That's going to be about 187.9. All right, so we've done plenty of examples using the law of sines. Let's go ahead and continue on to problem number 6, because remember we have 8 problems. So I told you today's lesson was going to be a little bit long, okay? All right, so let's see. I believe this one also requires the law of sines. I thought we were going to do the law of cosines, but let's go ahead and see what's going on here. Actually, let's look at one thing. In order to use the law of sines, you need to be able to use the angle and the opposite side to it. They both need to be known. Notice here, I don't have that. I don't know what this angle is. I have no way to figure out what it is. So This is when you realize I cannot use the law of sines. So what are you going to use? You're going to use the law of cosines. This one right here. Okay? So let's go ahead and determine what it is that we do know. Okay? We know what angle B is. We know what that is. Okay? We know what little c is, and we know what little a is. C is 14, and a is 11. So if you look at all three of these right here, which one is the one that you are going to use if you know angle B, A, and C? Let me try to get it all in the same image right there. All right, so I know angle B. Okay, so that means that I can use this one if I know what A and C are. And it so happens that I do. Okay, so my unknown here is going to be what little b is. So I know what A is, I know what C is, and I know what angle B is. So I'm going to be using this equation right here. Whoops. B squared equals A squared plus C squared minus 2AC cosine of B. Okay, so let me zoom in on that so you can see that what's going on here. All right, so we are looking for little b. Okay, so B squared equals A, which in this case is 11, C, which in this case is 14, minus 2 times 11 times 14 times the cosine of angle B, which happens to be 34. So notice that I can calculate all of this, okay, and figure out what I have here, because I'm looking for three things here. I'm looking for B, angle A, and angle C. So I might have to use the law of sines in just a bit. So B squared, that's going to be 121, 14 squared. That's 196 minus 2 times 11 times 14. That's going to be 308. Cosine of 34. All right. Now, calculate this in parts, guys. Don't try to put everything in the calculator all at once because it's going to get very messy and confusing. Okay, so when I multiply this, let's see, cosine of 34 times 308. I'm going to round to the nearest tenth just to make it easier. All right, so B squared equals 317 minus 255.3. And that's going to be 61.7. And when you take the square root of that to the nearest tenth, you're going to get about 7.9. Okay, so remember, we are looking for everything that's missing in the triangle. So we are looking for B. Sorry. Excuse my chicken scratch. We are looking for B. We are looking for the measure of angle A and the measure of angle C. Those are the three things that are missing in this diagram. So we just found this one, 7.9. Okay, so this part right there is 7.9. Now, how are we going to find either A or C? Well, now that we know what the side opposite of that angle is, I can actually use the law of sines. Sine of 34 over 7.9 is going to equal the sine of A over 11. Hence, now I can actually solve for this. Okay. Now, when you cross multiply, you're going to get 11 sine of 34 over 7.9 equal to the sine of A. Plug all of this into the calculator. All right, so I'm going to start with a sine of 34 times 11, all divided by 7.9. All right, so that's going to give me the following number. Now when I do the inverse sine of this number, I'm going to get the following. All right, so I have the measure of angle A to be approximately 51.1. Okay, so 51.1. So here's the thing. To calculate C, all you have to do is add the 51.1 and the 34 and subtract that from 180 degrees, which is going to give me approximately 94.9. Okay, let me zoom out. Okay, so how did I get that number? Well, all I did is I added this angle and this angle, subtracted from 180 degrees, and then I got 94.9. And that, ladies and gentlemen, is example number 6. Okay, so far we're at 41 minutes and we still got 2 more to go. Told you this lesson was going to be long, guys. All right, so pause the video if you need a little more time to copy it down, and then proceed once you're ready. All right, so ladies and gentlemen, let's take a look at this one. This one, we absolutely have no angles. So we need to find out every single angle. So I need to find out what the measure of angle A is. I need to find out what the measure of angle B is. And I need to find out what the measure of angle C is going to be. So these are the 3 things that I am looking for. All right. So that means I could really use any of the equations for the law of cosines, because I literally have all ABC, and it all depends what angle I'm looking for. So let's say we're looking for angle A. Let's look for angle A. Okay. We know little a is 12. We know B is 27, and we know C is 20. So I'm going to look for A first. So what I'm going to use is the following. The law of cosines. All right, so A is 12. B is 27. C is 20. Okay. All right. So let's go ahead and simplify this big mess. 144. Now I'm going to go ahead and do 27 square. That's going to be 727 plus 20 square. That's going to be 400. Now let me simplify the following. 27 times 20 times 2, 1080. Cosine of A. So this is like a 2-step equation. It's going to look very messy, but we're going to go ahead and solve for that. All right, so first thing we're going to do, get rid of this. So 144, take away 1129. Whoops, type that right. Oh. Here's a problem. I got fat fingers, guys. No offense to fat people, but I have fat fingers. All right, 985, and it's a negative. Negative 1080 cosine of angle A. So what we're going to do is we are going to, because it's multiplication, we are going to divide by 1080, both sides. Okay, so I'm going to divide that by 1080, and it's a negative, so I don't know where my negative sign is here. So that's going to be 0.9120 equal to the cosine of angle A is. So now what I'm going to do, since I already have this big old number, I'm just going to do the inverse cosine of this, and I'm going to get the measure of angle A be the cosine inverse of 0.912, and to the nearest tenth of a degree, that's going to be about 24.2. Okay, so angle A, 24.2. Okay, so now I have two options. I can do another law of cosines, or now that I know an angle and its opposite side, I can do the law of sines. So your choice. I'm going to use the law of sines because I think it's easier. So I'm going to do the sine of A over A. And I could either do B or C, doesn't matter. Sine of B over B, since I know all of these except for the angle. So the sine of A, that's the sine of 24.2 over little a, which is 12, equals the sine of angle B that we don't know what it is, but we do know what little b is. Little b is 27. All right, so then what you're going to do now is you're going to cross multiply. And you're going to go crazy here typing in all this stuff. 24.2 sine times 27, enter, divided by 12. That's going to give me about 0.9223 equals the sine of B. So what I'm going to do is the inverse sine of the following. And I'm going to get the measure of angle B to be approximately 67.3. Okay, so in order to figure out C, guys, it's really simple. Add these two together and then subtract that from 180 degrees. So I'm going to get the measure of angle C to be about 88.5. Now, I think what I'm going to do, I'm probably going to be taking pictures of these and putting them on Teams so that my students can actually have, the full copy of this. So pause the video and copy it down. And let's finally do our last problem of the day. This has been fun, guys. So this is literally the same strategy, okay? An organism's step angle, let me go in here, is the measure of walking efficiency. The closer to the step is to 180 degrees, the more efficient the organism walked. The diagram shows a set of footprints for a dinosaur. Find the step angle B. So in other words, they want me to find what angle B is. So I don't have to do everything else. I just need angle B. All right. So we're going to be using the law of cosines, the one that includes angle B. Okay. So that's going to be the following. Because we don't want to do everything else. They're not asking me to do that. So why do more work? Because it's fun. Okay, so we're going to be using this one because I do know what little b is. Little b is 316. I do know what a is. A is 155. I do know what little c is, which is 197. So that's going to be 155, 197, cosine of angle B. All right, so let's get simplifying this. 316 square, it's a big number, so give yourself enough space. 99856. Now I'm going to add 155 square, okay, that is 24025 plus 197 square. Okay, multiply 2 times 155 times 197. That is 61070 cosine of B. Very messy, but nothing we can't handle. I'm going to combine these two. 24025 plus 38809. All right, two-step equation. Subtract this, then divide by that. All right, so we're going to subtract 62834. Okay, 62834. So 99856 minus 62834. That's going to give me 937022 equal to negative 61070 cosine of b. So division time. With these kind of videos, guys, it's probably easiest to watch the video first and probably do the notes afterwards, because it involves a lot of thinking, you know, to keep up with this. So that's going to give me negative, now let me make sure I'm doing this right, okay, negative 15.34. And now you're probably thinking, wait a minute, the cosine is a negative. Oh, you're going to see what's going to happen. When you take the inverse cosine of that, whoops, because you can take the inverse cosine of a negative number, and guess what you're going to have? So 15.344 negative inverse cosine, whoops, okay, pause. Okay, so I found my error. My error was actually in my subtraction. Okay, so it's actually not this. So I knew I was doing something wrong. So 99856, take away 62834, and that gives me 37022. Okay, apparently that was my mistake. So divided by 61070 negative, and I get definitely not that number. See, teachers make mistakes. That's okay. 0.6062. Then you do the second inverse cosine of that angle. Sorry, it looks a little messy. Let's go ahead and rewrite that. And voila, we have found the measure of angle B. Okay. Take about a minute or two and go ahead and copy it all down. So I told you 9.7 was going to be very long, 53 minutes. All right, thank you for coming, and thank you for watching, and we will see you next time.